Yes, hi everyone. So, welcome to PyNet Labs. My name is Jatin, and I am going to be your instructor for this webinar. So, this is gonna be a very interesting webinar. So, in this webinar, we are going to see like what makes the OSPF the best IGP routing protocol. So, as we all know that IGP is a routing protocol which is having multiple different protocols inside, and IGP is basically used to exchange the routing information within the same autonomous system. So the original intent of this protocol was to create within some boundaries of that network. So today we are going to look more in detail about the OSPF, and that's why it is widely being used. So if I'll be starting with a quick introduction to the OSPF, so you will see that as we all know that OSPF is an IGP protocol. So the first thing about the OSPF is that OSPF is an open standard protocol which is widely being used in most of the enterprise networks, and we can say that it's a loop-free routing protocol when it comes to OSPF. So it's totally loop-free. Because how it is loop-free, so we are going to see like whenever we are going to be execute the labs on OSPF.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
Then it is going to introduce the concept of areas as well. We have some area concept here as well. So we will see that what exactly the area concepts are. So this protocol itself minimizes the overhead, like this OSPF whenever we are talking. So in broadcast networks or in multicast addresses, like in the broadcast network, multicast addresses are being used instead of the broadcast, which we all know, and to reduce the interference of the other network devices so that do not operate with the OSPF, or like we can say OSPF is used in OSPF is used in ISP networks as well as it is used in the enterprise networks. So that's what make it OSPF as a widely used protocol. So in this webinar we are going to look more in detail about the OSPF. So there are many questions about the OSPF, it's a very vast topic which cannot be covered in 1 hour, but yes, we'll try to show you some things which are you haven't seen in any of the YouTube videos. So as we all know that OSPF is basically a link state protocol, and link state means that it is going to use the incremental updates, and it's a classless routing protocol which is going to support the FLSM and VLSM subnetting as well. So here the best thing is we have the unlimited hop counts, so there is no count of routers, so you can use maximum routers here, and it is going to support the FLSM and VLSM subnetting. So here we are going to update the the updates are sent via the multicast address, which is 224.0.0.5. One more address is there, 224.0.0.6, so which we are going to look it out later on. And we can say that it is having the fast timer convergence as compared to the distance vector protocol. It's having faster convergence. So faster convergence means here we have the 10 seconds of hello timer, and the dead timer is of only 40 seconds. So this is a quick introduction to the OSPF which we all are familiar with. So if you will be looking at there is a finite mechanism in OSPF, so we can call it as the working of OSPF in just simple words. So in OSPF, whenever we look at the working of OSPF, so we have some 7 stages in the OSPF. So let me write down the name of all these stages, and parallelly I will explain you all the stages. So the first stage in OSPF is the down stage, and the down stage is nothing but the ports whenever we connect to the routers for the first time. So as we all know that ports are in the shutdown state. Then we have the init stage. So in this initialized state, we are going the routers. For example, if this is your router and this is your router 2, so I'll be writing router 1 and router 2, and both are connected via a link together. So for example, if you have connected both of these routers together, so this router is going to generate some hello message for the first time, and that hello message is sent via 224.0.0.5, which is the multicast address. So in this initialized state, they are going to send their hello messages, hello packets are being exchanged. So then comes the third stage, which is your two-way state. So in this two-way state, here they are going to establish the neighbor relationship, because they have exchanged their hello packets and now they are becoming their neighbors with each other. So they have exchanged their neighbors hello packets and they are going to establish the neighborship relation with each other. Then comes the fourth stage, which is your exstart stage. So in this exstart stage, we have a selection of router ID. So here the router ID is being decided. So we can say, and router ID is basically nothing but the name of the router which is being identified over the OSPF process. So here the higher router ID is going to start first. Like we said, higher ID we can write. So a router ID is nothing but if you will take, for example, let's take this router, or let's assume that we have some address of 10.0.0.2 here, and we have another interface of this router which is connected via 1.1.1.1 network to some other router here which is having .2 address. So on this router 2, on this R2, we have two interfaces, so 10.0.2 and 1.1. So router ID is nothing but the name of the router. So router ID is something like the highest active physical interface of the router is going to be have that particular router ID. But if you have configured any loopback address, so that loopback will be considered as the highest router ID in that case. But if no loopback is considered, like if no loopback is being configured over that router, so in that case the highest IP of that active physical interface is gonna be the router ID of your OSPF process. So here this will become the router ID, which is 10.0.2, because on the active physical interface, this is the highest IP because this is the lowest as compared with 10 network. So this is what happens in the exstart stage, that the router ID is being selected, like they are going to exchange their router IDs. Then in this exchange state, so in this exchange state, they are going to exchange the summary of their databases. Exchange the summary of link state databases. So you will see that link state databases, so we have basically like some types of OSPF packets here, so which I will be explaining you later on in upcoming labs which we will be doing. So there are some databases which all the routers are going to exchange once they are going to build the neighborship and the routing has been done inside the topology. Then comes the sixth stage, which is your loading stage. So this loading stage is nothing but like they are going to verify their databases. The databases which are being exchanged on this fifth stage, which is your exchange state. Then we have the last, which is your full stage. So in this full stage, they are going to synchronize the information which they have verified with each and every other router. So these are the 7 stages through which your OSPF is going to work, and we can say that on this working of OSPF, like whenever we are working on the OSPF, so at the backend these stages are going to work, and I'll be showing you in the labs as well. So as I was talking about these link state databases, that they are going to exchange their summary of the databases. So how, like what kind of summary and what type of packets they are going to exchange. So after like working, there are some terms in the OSPF which we do need to understand. So we have some LSAs here. That is the most important part of this webinar. So LSA stands for link state advertisement. So I'll be letting you know what exactly these link state advertisements are, because nobody talks about these LSAs when it comes to the OSPF, because that's something which makes this webinar different. So after the LSA, we have some LSDB, which stands for link state database description. And then we have some SPF, which is shortest path first. Shortest path first. So if you will be talking more in detail about these LSAs, so like if we will be discussing these LSAs, so this LSA like we have discussed here. So if I'll be writing separately, so we have link. So link is nothing but the interface of that router. Interface of the router. And then after the link, we have the state. and that state actually, like, it's the state of that link is the description where the interface and its relationship with that neighbor are going to build in that state. So in this state, it includes, like, we can say it is going to include the IP address, it is going to include the subnet mask as well as, like, we can say routers connected to the interface. So we can say these are some informations. And when it comes to the LSDB, so this basically contains of all the link starts from the link state databases, and it needs to be identical as per the area. So I'll be showing you practically when we will be looking more into details of the LSA. So whenever we are talking about these LSAs, so for example, when a router generates or modifies the LSAs, because like OSPF is basically a dynamic protocol, we call it as like it's a part of dynamic routing, so, and it's a part of IGP as well. So we all know that they are going to work on the advertisements. So when a router generates or modifies the LSAs, it must communicate to the changes which are being throughout the network. So routers always start this process by sending their LSAs in case of OSPF to each adjacent router. For example, if we have connected this router, this is your R1, and we have connected this R1 with R2 here. So once we are going to configure the routing on both of the interfaces, so they are going to build their adjacencies and they are going to build the neighborship relation between both of them routers. So you will see like how they are going to work in case of dynamic routing. So they are going to generate the LSAs, which I'll be showing you practically. So there are some types of LSAs and we are going to discuss each and every type of the LSAs. So basically, these are something like we call as link state protocol data units, and they are going to use the multicast address, which is 224.0.0.5 and 224.0.0.6. So now see guys, let's do some lab and let's execute the scenario. So I'll be sharing my lab screen. So this is our topology and I'll be showing you the OSPF lab in this scenario. So what I have done is, like, basically right now I have only assigned the IP addresses in all these machines, and I'll be showing you. Let's go on this VIOS1, which is my router 1. So as you can see, this is my R1 screen and I'll be writing the commands. So if I'll verify show IP root, so you can see as such no roots are there. These are the locally connected roots. And if I will be writing show IP OSPF neighbor, so no neighbor is there because I have not done any kind of routing in this scenario. So I'll verify you the IP addresses, show IP interface brief. So you can see that on the gig 00 interface of this R1, I have assigned this IP 20.0.0.2, and for the reference I have also mentioned the IP address here. So now I'll be verifying the same on all the routers. We can verify on the VIOS2 as well. So if you will see show IP interface brief. So we have already assigned the IP addresses, and let's get started with the commands and execution of the OSPF. So no OSPF is configured in this topology right now. Only the basic configurations like the IPs which are mentioned about the given interfaces. So that IPs are there inside this. We have assigned these IP addresses over that interface. So now if you will see that what exactly we are going to do in this scenario. So we are going to create some OSPF lab here. So you can see as like in OSPF we have two types of areas. The first is your standard area, and like the next is your backbone, or we call it as the transit area, which is the area 0. So we are going to create a multi-area lab in this scenario where this link, this 10 network will be remain in the area 10 here, and this 12 network will be a part of this 20 area, and the middle routers like VIOS3 and VIOS4 will be the part of area 0. So I'll show you some labs here. So first of all, we will be going with the VIOS2 and we are going to configure the routing here. So before that, I'll show you something. So on R2, if I will write show IP OSPF database, so as you can see, if I will be writing this command, it is showing me no database. And if I'll verify show IP OSPF neighbor, so you can see no neighbor is there. show IP route. If we will verify, so no IP route is there, like all the local connected and directly connected routes are there. So we are going to execute the command of OSPF routing. So configure terminal IP route, sorry, it's router OSPF 1. This OSPF 1 like is basically the process ID. Now we are going to assign the network here. Which network we have? 10.0.0.0 and 0.255.255.255 is basically the wildcard mask, and we are going to put this in the area 10. Okay, fine. So this is something we have done on the R2. Now if you will see that, I will show you something. Show IP OSPF database. So you can see now one LSA has been generated, and this LSA is known as router link state. So basically whenever we are establishing the link, so this all the OSPF routers generates the LSAs for each of their area to describe that they are attached directly within the intra-area routes. So like this router link state, if you will verify on the other router on the VIOS3, I'll show you. So you can see there will be no OSPF database. So you can verify show IP OSPF database. So as of now on R3 there is no database, but still as I have only configured the route for 10 networks, so it is generating one LSA. So advertising router is 20.0.0.1. So like it's taking this, like it's advertising because we have already assigned this IP address on that router, and link count is something 1 here, and sequence number, as we all know that every time whenever we are going to execute the configuration, so the number is going to be increased. So whenever we are talking about this router LSA, so LSAs includes, like these router LSA includes the directly attached links, and it is identified by the router ID of that originating router. So right now you can see do show IP route. So as such there is no route because we have not configured on the other network. But if I am going to configure, see on R2 we have configured the routing, and I'll be going on this router which is your VIOS3, and I am going to configure the command. So you can see on this gig 00 I am going to configure the OSPF database. So previously we already verified, but I'll show you once again. See, no database is there. So once I am going to configure the OSPF here, see what happens. Router OSPF 1 network, we have 10 network here, 10.0.0, 0.255.255.255, and this will be a part of your area 10. So once I am going to execute this command, so you will get a log that they have built the neighbor agencies, and like see, we have got the agency log that they have built the agency, the process ID used is 1, and the neighbor is 20.0.0.1, and all the stages which we have discussed are now done, loading to full. Now if you verify do show IP OSPF database, so you can see that here one router link state has been generated, but one network LSA has also been generated. But let's understand this router link LSA first, because like as I told you that it floods within the area only, it cannot cross the area border routers, so it will remain in the like in the routers which are configured with the OSPF, but they will not be flooded out of the network. So in these LSAs we find those link states which are directly connected to the routers, like the IP prefixes of the interfaces, like these are the IP prefixes of the interfaces, and the type of link, like what kind of link it is using. Like you can see link count is 1 here, 1, and if you will verify again on the router 2 here, so you will see that R2 will also generate the same. See, in on R2 also we got the same log that the loading agencies has been done. So now we'll verify same here, do show IP OSPF database. So you can see that router link state LSA, the type 1 LSA is also generated, and the type 2 LSA netlink LSA, network link state, has also been generated. So when it comes to the OSPF network LSA, so this LSA is a type 2 LSA which is your network link state. So like packets are generated by the designated router. So if you will verify the show IP OSPF neighbor, So you can see that this is the backup designated router. But if you will verify the same thing on the R1, or sorry, on the R3, where we have configured the routing. So if you will verify here, do show IP OSPF neighbor. So you can see that it is the designated router. So like this 20.0.0.1. So all these LSAs are being generated by that designated router, these network link state, and to describe all the routes which are connected inside the segment directly, and like LSA type 2 are flooded within the between the neighbors in the same area, and the origin will remain in that area only. So this is how we are going to see these kinds of LSAs. So this is something, the type 1 LSA, which is your router LSA, and the type 2 LSA, which is your net link state LSA. So these are the two types of LSAs. So network LSAs are generated in multi-access networks by the designated router, or if you are talking about the broadcast and non-broadcast multi-access networks, so we need like DR and BDR. In these LSAs we can see all those routers which are part of the shared network, and we can also see the IP address of that particular LSAs, like as it is showing us like the IP which is giving the neighbor ID. So this is how the type 1 and type 2 LSAs are being generated. So the third type of LSA, whenever we are talking about the third type of LSA, is something like which is only generated when you have configured some multi-area concepts. Like right now we have only configured the single area concept, because on R2 and R3 we have configured the OSPF. So on R3, if you will be checking, like see if you can verify show IP OSPF database. So only two LSAs are there. See, only the LSAs of area 10 are there, because we are using the single area concept in the scenario. But when it comes to the summary LSA, which is your type 3 LSA, so what happens in that case, like it is always advertised by the ABR of that originating area. So whichever the area is originating, that like the area border router is going to originate that type 3 LSA, which is your summary LSA, and it is regenerated by the subsequent area border routers to flood throughout the AS, we can say, or by default the routes are not summarized, and the type 3 LSA is something which is advertised on every subnet. So if we are going to configure on R3, so we can see, like I'll be going on the configure terminal. Now I'll be assigning the area 0. So I am connecting this gig 01. I am putting this gig 01 in the area 0. So router OSPF 1 network 11.0.0.0 and 0.255.255.255, and area will be your 0. So as I have advertised this to area 0, and now you will see do show IP OSPF database. So you can now see, once I have advertised the area, so we have generated one summary netlink state. So this is going to generate by the area border routers, and this is the type 3 LSA here. Now you can see that area 0 information is also there, which like they are all connected, like this is the connected route to the area 0, and the summary link state has also been generated here. But previously when we were checking, so only the router link state and the net link state was advertised. Like as I told you that this type 3 LSA, which is the summary LSA, is being advertised for every subnet. So if you will be looking out on the R2 as well, so again you will verify do show IP OSPF database. So you can see that it is being generated on every of the subnet. So it is being generated here as well. So as we know that type 1 LSAs are restricted only to their own areas, as we know also that like OSPF works on multi-area approach, like multi-area concept we have in OSPF. So we need to have the detailed information of all these areas, and R1 is going to generate that router LSAs and flood it into its own area, because LSA1 and LSA2 are not flooded out of the other areas. But if you have configured the multi-area concept, so it is going to create one more LSA, that is your summary LSA, like which is your type 3 LSA, to advertise the inter-area routes information to the areas to the ABR which are directly connected, or they use the prefixes accordingly. So these LSA type 3 packets are flooded to the, we can say, multi-areas throughout the network to help the OSPF scalability to use that summary of that advertised routes here. So these are the types of LSAs. So so far we have discussed 3 types of LSAs. The first is LSA1, the next is your LSA2, and the third is your LSA3, which is for the multi-area concepts. Now the fourth type of LSA is something like which is like you can say summary ASBR LSA, which means like for that we have to go with the redistribution lab. So for example, right now what we have seen is we have configured the routing on these domains only till this part, like on this router 2, router 3, and we have not done any kind of routing on these routers. But what I am going to do is, let's say this is your R1 and we are going to configure on this router 2 as well. So we are going to configure some Eigrp on the R1. So I am on the R1 screen, so I'll show you. So we are on R1, enable, and I'll show you show IP interface brief. So you can see here that gig Ethernet 00 is having the IP address of 20.0.0.2, and now you will see that I am going to configure some Eigrp protocol here. So if I'll be creating router Eigrp 10, let's say, and I am going to advertise the network which is 20.0.0. So I have advertised this network 20.0.0 in the Eigrp domain. So if you will verify show IP root, so you can see it's not showing, but if you will verify show IP protocols, so you can see now the routing protocol configured is Eigrp 10 on this R1. So as such, on this route, like we have only advertised this 20 network, nothing else we have advertised apart from this router. Now we'll be doing on the R2 as well. So here we are on the R2 and we are going to advertise, like see, I'll show you first. Show IP protocols. So you can see that right now here the configured routing protocol is the OSPF 1, which we have already configured for 10 network, and nothing else is showing here. And if you will verify show IP route, so it is showing you all the routes which we have connected. So it is showing you an OSPF inter area, which basically we have connected via the 11 network, which is a part of your area 0. So for that the summary LSA was generated. But right now we are looking more into the fourth type of LSA, which is your summary ASBR LSA. So here I am going to configure Eigrp. So router Eigrp 10, and the network we are going to advertise is 20.0.0. So now you can see that Eigrp is a dual, like it's a hybrid protocol. So like we can say it's an advanced distance vector protocol. So it works on the diffusion update algorithm. So here it has done the neighbor with that particular router, and we can say that neighbor is 20.0.0.2. But right now if you will verify show IP OSPF database, so you can see only the summary network link state is there, the network link state is there, and the router link state is only there. But what we are going to do is we are going to look out more in detail about the summary ASBR LSA. So which is generated by the ABR of that originating router to advertise to that ASBR, which is autonomous system border router, or we can say to all the other areas in that AS. So they are generated by all the subsequent ABRs to flood throughout the AS, because we are going to redistribute this route here, because right now or this router, this R1 is basically a part of Eigrp domain, but here inside this till this part, like 10 network and 11 network are basically a part of your OSPF domain. So we have to redistribute the Eigrp routes into the OSPF network, so that the, like in that case only the R2 will be acting as the ASBR here. And now it will change something to the router LSAs. Basically it is going to generate that it could become the ASBR, and it will flip a bit internally. So we'll see how we are going to do the redistribution. So we are going to redistribute the routes on this R2. So I'm going on the R2 here. So but before that, once again you can see OSPF database, only 3 LSAs are there, LSA1, LSA2 and LSA3 is there. So I'm going to redistribute the routes here. So here I'll be writing router OSPF, the process is 1. Now redistribute Eigrp, and the AS number for Eigrp I have used as 10. Now we are done with the redistribution here. Again router I have to redistribute Eigrp as well. So, and the Eigrp AS number was like 10. Now we have to write redistribute OSPF, and we have to write a keyword here, which is your we can see the process ID which we are using, and then we have to write this metric, because like Eigrp is going to use some metric, so we will be writing this metric. So after this metric, if you will see that we have to select the bandwidth here. So the bandwidth we are going to select here is, like, for example, we will be selecting like 100 Mbps. So once we have selected the bandwidth, then we have to select the Eigrp delay metric, because you all know that Eigrp is going to use the k values. So we have to write 100 here as the delay. And now it is asking us for the Eigrp reliability. So reliability, let's say we are going to select more reliability as 255. And if you will again put question mark, so it is asking you for the load here. So load by default we are going to write 1 here. And if you will again, so it is asking for the MTU of that path. So by default size of MTU is 1500. So we have redistributed the route, like bandwidth we have already used. Then after bandwidth we have used the delay, load and MTU, all the metrics of k values. Now you will see that as I have redistributed, so you can see show IP route. If you will see, so it's showing that OSPF inter area, but let's try to verify OSPF database. So now you can see that type 5 LSA is being generated, which is the AS external link state here, which means like this is your summary ASBR LSA in case of your type 5 LSA. So this is what the concept of your type 5 LSA is, and it is always advertised by the autonomous system border router. And if you will see that this is the type 5, and if you will be looking more in detail on these other routers, so if you will verify on the router 3, so here also that routes will be generated. So you can verify show IP OSPF database. So you can see that here also we have generated the type 5 LSAs. So this is how the concept of these LSAs are going to work, and this is how, like, and see, this is basically summary ASB is basically your like the type 4 LSA, which is like not mentioned. So these are type 4 5 LSAs. So this type 5 LSA, like, which is your ASBR external LSA, like it is also mentioned here, external link state. It is generated by the ASBR router to advertise the external redistribute routes in the OSPF AS. And typically an example of LSA type 5 would be an external prefix, which like you are using some routing with Eigrp, or like as in our scenario we have used the Eigrp routing. But if you are using some other routing, so it is going to show you that as well. So if you will see the routing table, show IP route, so you can see that here it is showing you E2, like because external routes are advertised inside this routing domain. So that is how, like, these are the types of your LSAs which we have already seen in your OSPF scenario. So these are some types of LSAs. Then we have some type 6 LSA, which is, we are not going to use that LSA types in OSPF, so that is a kind of multicast LSA. So these are some types of LSAs which we are going to look out, and there are some various types of OSPF LSAs, like OSPF type 8 LSAs, they are 9, 10 and 11 is there, but those LSAs are not being used in the OSPF because they are for the different vendors. But in CISCO we have some LSAs like type 1, 2, 3, 4, 5 and like 6 is not being used. So these are some types of LSAs here in the OSPF as we have already verified. So if you will verify show IP OSPF database, the first type of LSA was the router link state, which is the type 1 LSA. Then we have the summary network link state. So basically, like, this is something the type 4, then summary ASB, like, so this is the type 4 summary ASB, and this network link state is the type 2 LSA. This is the type 3 LSA. And we do have the type 5 LSA as well. So that is what makes the OSPF, like, a very kind of, we can say, a good or like less overheaded protocol, because in OSPF we have separate LSAs for separate configurations, because as we have seen that in these cases, like whenever we are looking out, so every router is being generating its own LSA accordingly. So that is how that makes the OSPF different. So if you will be looking more in detail about these things, so you can find the reference guides as well. So we'll be sharing that as well with you in the descriptions. So right now I'll be summarizing all these LSA types here. So if you will see, like if I'll be summarizing all these types of LSAs, so we have some types of LSAs which we have discussed. So if I'll be writing down, so the first type of LSA we have discussed was the router LSA, which is basically the type 1 LSA. So this is the type 1 LSA. Okay, wait a sec. Yeah. LSA 1, which is known as your router LSA. So this router LSA, the advertising router of this router LSA is, I'm writing here, advertising router. The router which advertises this LSA. So like the OSPF routers, the default routers where you are configuring the OSPF. So they are going to advertise. And what are the content of this, like we can say contents which are includes in this LSA. So here we have some topology and routing table information. So we can say topology table and routing table information here. And then the next type of LSA is your LSA2, which is your network LSA. So this LSA is generated by the designated router always. And the same thing, the content here, it is like the topology and the routing information, and advertising scope of this network LSA is like only in the local areas, not apart from that other areas. Then we have the LSA3. So in this LSA3, like which is basically your summary LSA. So this summary LSA is always advertised by the area border router, which is basically, we can say, like the information which it is going to include is something like the inter-area routing information. Inter-area routing information. So these kinds of informations are like basically, used in these kinds of scenarios. Then we have LSA 4, which is your ASBR summary, which is widely used, we can say in case of redistributions, if you are going to use the redistributions. So you do have to configure all these redistribution here. And then we have something like the advertising routers. Here are like the area border routers. And the content here it is going to advertise, which is ASBR router ID. And then we have the LSA 5, which is like your type 5, or we call it as AS external LSA. So this is your type 5 LSA, which is generated by the ASBR routers. And it is something like, we call it, the content here is something which is the redistribution content, which we have already seen in that case. So here we have ASBR router ID, we can say, or like ASBR router IDs is also there, and external routing information is also there in this part. So external routing info, if I'll be writing. So this is something which your LSAs are going to be a part of, like your OSPF, and these kinds of LSAs are going to, make your OSPF kind of very heavyweight protocol. And that's the reason why we are using this OSPF in the enterprise network, because every time these routers, like all these LSAs are being generated on the types of configuration, either you are going with the redistribution, or if you are using single area or multi areas. So these LSAs are actually going to make this OSPF as a less overheaded protocol. So apart from that, we have some more LSAs here, like we have LSA 6 here in OSPF, if you will be looking out. So this LSA 6 is something like, we call it as multicast LSA. So this multicast LSA is something like, when the packets are designed for the multicast OSPF, or we call it as MOSPF. So a protocol that support multicast routing through the OSPF, and it is not supported by CISCO. So I'm not writing anything about it because it's not supported by CISCO and widely used, and it's some expected, and it will be retired soon. So we cannot use like this Lsa 6, but we have some Lsa 7 as well. So Lsa 7 is something like we have some like in case of NSSA external routes, not so stubby area, external Lsa. So when it comes to the Lsa 7, so like packets are used for some special areas that you do not allow to the external distributed routes to go through, thus block the type 5, type 7 LSAs. So basically, like to configure this is supported by the CISCO, but we are not looking more in detail about this, because for that we have to go with the multiple area configurations and so on, things like that. And there are some LSAs like Lsa 8 is also there. We have Lsa 9, 10 and 11. These are some part of your LSAs as well. So these are basically some LSA types in OSPF, but these Lsa 8 and like Lsa 9, 10 and 11 are not used, being supported by the CISCO routers. So we are not going to discuss all these things. So this is something which we have already discussed about the OSPF LSAs, and that's what make the OSPF the best IGP protocol, and so many things are there, but this is something, a quick introduction to the LSAs and some detailed knowledge about all of these LSAs, that what kind of information are being used in these kinds of scenarios and so many things like that. So if you will be talking about all these LSAs, so we have some OSPF messages and packet types in these LSAs. So if you will be looking out more in detail about the packet types, so in OSPF we have some packet types when it comes to the LSAs. So the first one, we have the hello message, as we all know. So this hello message is nothing but like to exchange the hello messages, they are going to build their neighborship tables and all that stuff. Then the second we have is the database description, and here like we can say LSDBs are exchanged. So these LSAs are being exchanged here. Then we have some link state request. So this LSR is something link state request, and then we have some like we can say link state update, and after that link state update we have the last one, which is your LSA, which we have discussed more in detail. So these are some like the 5 messages of OSPF, and these messages are known exactly as LSAs. And whenever we are talking about these LSAs, so these LSAs, link state advertisements, are the backbone of your OSPF. So LSAs basically we can say they are going to act as an database record when combined. So they describe the entire topology of the OSPF areas when it comes to the OSPF configurations. So that is all about the OSPF basically LSA types. And to wind up, we can wind it the OSPF by completing with the metric solutions. So as we all know that in OSPF we have some metric calculations, that the OSPF is going to calculate the best path basis on the metric calculation. That is something like we call it as the cost. So like there are many types of routes in the OSPF, as we all know that something like the OSPF is the normal OSPF route. Then we have OSPF inter area, as we have already seen that. So then we have OSPF E1 and OSPF E2 in case of redistributions if you are going through. So by default that E1 is always preferred if you are going with some redistributions. But see that OSPF uses the cost as its metric to find the best path. And it is true but not entirely true, we can say, because the OSPF first checks the type of the path to make the decision and then check its metric. So it's something like the routes are always followed like this. We can say that OSPF is given the highest priority, then the inter area is given the highest priority, then after we have E1, and then we have E2. So like these, the priorities of the OSPF routes are given to the OSPF metric calculations. So like there are some default bandwidths in OSPF. So according to that, they are going to figure out the OSPF best path to calculate like who is the best path and who is going to win that best path route. So who will be the kind of we can say which one is going to be the best part. So for every kind of link we have some default bandwidths. Like if you are using some serial link, So for serial link, if you are using, so the default speed is 1544 kbps. And as we all know that the formula to calculate the cost in OSPF is 10 raised to power 8 divided by the bandwidth. So if you will be dividing 10 raised to power 8, like for example 100 Mbps, if you will be dividing like this 1 2 3 4 5, that's 100 Mbps, 10 raised to power 8, and we have 1544 kbps. So the cost it is going to generate, the cost will be your 64. And if you are using some Ethernet link, so in this Ethernet link, like we have some by default speed of 8 kbps, and we have the formula, like it is going to use that same formula where it is going to divide accordingly by the bandwidth, because in that case the cost it is going to generate will be 10, because like here we have like this, it is going to be used. And then if you are gonna divide all these things together, so this will give you the cost of this. If you are using some fast Ethernet links, so in that case the fast Ethernet links are having some like speed of 100 Mbps, as you all know. So the cost for the 100 Mbps of the links, we can say the cost comes here is something like 1. Or if you are using some gig links, so in that gig links the cost comes like, the cost is always the 1. So that's what the OSPF that's what makes the OSPF difference. And that's all in the OSPF. Now any queries you people have, so you people can now raise your queries. So that's all from this webinar. Like I hope you people will find it a really interesting webinar about the OSPF. So to check more in detail, you can visit the website of PyNet Labs. There are so many resources related to the OSPF and the lab guides as well. So you can go through with the website of PyNet Labs, and you will find a lot of content related to the OSPF and all that things more in detail. So I hope you people find this session very interesting. So thank you very much for joining, everyone.